Hey everyone. Today we're going to talk about, well, pretty much everything. We're going to break down what the entire world around us is made of, from the screen you're looking at right now to the air you're breathing. I mean, have you ever really stopped to think about it? If you could boil down the whole universe to just one single ingredient, what would it be? Well, in this explainer, we're actually going to answer that very question. So let's dive right in. This huge, almost philosophical question. It actually has a surprisingly simple and elegant scientific answer. It's the one concept that's the foundation for all of chemistry and physics, and it explains all the stuff in our world. And that answer is matter. That's it. Simply put, matter is anything that has mass, some heft to it, and takes up space. It's the physical substance of the universe. And this definition is really important because it separates all the physical stuff from things like energy, light, or sound. Think about it. From giant stars to the tiniest living cells, it's all just matter. And all the incredible variety we see in the world comes from one simple fact. All this matter is made of tiny particles, like the atom you see here. The only difference between a solid rock and the invisible air is just how these little particles are arranged and how much energy they've got. Okay, so now that we know everything is made of these particles, let's explore the three classic states or forms that matter usually takes. We'll start with the most rigid one, solids. Right, so in a solid, the particles have pretty low energy. They're all locked into a tightly packed, orderly structure, kind of like they're holding hands and not letting go. They might vibrate a little, but they can't actually move around. And that's exactly why a solid keeps its own shape and its own volume. Now, what happens if we give those particles a little more energy? Well, you get a liquid. In a liquid, the particles have enough juice to break those rigid bonds and start sliding past one another. This is why a liquid can flow and take the shape of its container. But since the particles are still packed pretty close together, it still has a definite volume. But what happens when we give the particles enough energy to just completely break free from each other? Well, that brings us to the most wild and free state of matter, gases. And this is where it can get a little tricky, right? I mean, we're literally swimming through air, a mix of gases all the time, but we can't see it. So how do we know it actually has mass and takes up space? How can it be matter? The answer is absolutely yes. Gases are matter. It's just that in the gas state, particles have so much energy that they're flying all over the place, really far apart from each other. They'll expand to fill up any container you put them in, no matter how big. And because the space between particles is so huge, most gases are totally invisible to us. And here's the proof. Even though we can't see the air itself, we see its effects everywhere. That wind blowing through the leaves, that is literally the force of trillions upon trillions of tiny gas particles crashing into them. It's visible proof of invisible matter doing its thing. Okay, so we've got our three states: solids, liquids, and gases. But here's where it gets really, really cool. These aren't separate, locked-in categories. The most amazing thing about matter is that it can change from one state to another. Just think about it for a second. Is an ice cube a different substance than a glass of water or the steam coming from a kettle? Nope, they're all H2O. The only thing that's different is how much energy the molecules have. And that is the big secret. The state of matter isn't a permanent identity. It's just a temporary condition. By adding or taking away energy, usually as heat, we can make matter transform. We call these changes phase transitions. Let's just walk through how melting works. You start with solid candle wax, where all the particles are locked in that neat structure. Then you add heat. This gives the particles more energy, and they start to vibrate like crazy. Eventually, they vibrate so violently that they break free from their fixed spots. And that whole solid structure just collapses into a flowing liquid. And it's not just about melting. The same basic idea applies to boiling, when a liquid turns into a gas, or condensation, when a gas turns back into liquid, or even something called sublimation, where a solid can turn straight into a gas. These incredible transformations are happening all around us, all the time. So, why should we care about all this? I mean, it's cool science for sure, but this isn't just about textbook definitions. Understanding how matter changes state is absolutely critical to how we understand and even build the world around us. Seriously, think about it. Every time you check the weather, you're looking at a forecast based on water changing states across the entire planet. The steam engine, which literally powered the Industrial Revolution, was just a machine designed to take advantage of how much water expands when it turns into a gas. Even the strength of the steel in our skyscrapers is controlled by carefully managing its change from a liquid to a solid. And understanding these three basic states just opens the door to even wilder stuff. Did you know that 99% of the regular matter in the universe isn't a solid, liquid, or gas? It's a fourth state called plasma. And if you get things super, super cold, you find bizarre quantum states of matter. The journey to understand what everything is made of, it's really just getting started. What do you think we'll discover next?